Great. Thanks for joining us today from different time zone. As you know, we are based in Australia. It's 4 a.m. on Thursday. We usually say that we are from future. We are very excited to see you here. If we haven't spoken before, my name is Golly. I'm the VP of Customer Success at FlexRule, and I have Arash with me. Arash is the FlexRule founder. In our today's workshop, we are talking about what is decision automation, why do we need it, and how we can get the most out of it. Before we start, we have a few housekeeping items. First of all, we are recording this session. If for any reason that you need to jump off, don't worry about it. We will send you the recording session later on with you. And we love to hear from you. There is a chat box in your Zoom application. If you have anything that you need to share with us and you like to share, please go ahead and put it there. As a start, we love to hear from you that from what country or location are you joining. Great, thank you so much. And we would like, at the end of this session, we would have a QA. And there is, again, in your application, Zoom application, there is a QA box. There is, during the session, if you have any questions that you like to ask, please put it there and we will make sure that we will answer your questions. Great. Arash, stage is yours.
Excellent, excellent. Thank you very much, everyone. Thanks for joining. It's a little bit stormy at the moment in the Melbourne, so if you hear any noise, apologies for that, but we can't do much about it at the moment. So a little bit story about FlexRule. FlexRule was founded back in 2008. We have customers across the globe, and we have, interestingly, across all industries, from education to health to insurance to financial organizations, startup to government agencies. And our mission really at FlexRule is to empower all the leaders, business, operation, and technology to improve speed and quality of key business decisions in changing environments. And that's what we are aiming for. During this workshop, if you have any questions, as Golly mentioned, please put them in the QA channel. So we are looking for receiving questions, and we're going to be answering them at the end of this session. Now, in organizations, there are literally millions of decisions are made every day, and hundreds and thousands of different kind of decisions. So let's have a couple of examples here. For instance, next best offer in financial institution, in insurance, allows them to put another different bundling when you have a transaction where you purchase some insurance, they offer more products. That across different industries. So product recommendation can be seen as the next best offer. Product configuration. So organizations try to provide highly customized products to the consumer. So just again, as an example, if you look at, for example, you're taking an insurance, there is not only one product from the organization's point of view. There are multiple of them, but there are so many different variations of that particular product. They try to meet the individual needs with this product configuration decisions. Credit approval, so how much a person can borrow from a lender, is a very complex decision that is part of the loan origination, for example, process. So these are just a couple of examples in different industries, but you can think of any particular decisions made on the floor of any organizations that impact internal staff or the consumer. That is a decision. Literally millions of them are made. And interestingly, because the volume of these decisions and the importance of these decisions, they determine the business operation quality. So organizations are having different approaches to automate business decisions. They go with different tooling and solution, business rule, business process automation, decision management, RPA robotics, machine learning AI, custom code development, Excel, scripting, anything you think of. Now, we want to understand what your organization is going to use or are using at the moment to automate any types of decision. So there is a poll here, and
yes, I'll bring up the poll.
We're going to see the results.
Please. Okay. Great.
Please don't be shy. Participate in the poll. It's very interesting for us, and we want to understand what are you using today to automate any types of decision across different part of the organizations, in the sales, in the marketing, in product development, in operation, wherever it is that you know of. Excellent. Very interesting result. So thank you very much for participating in the poll. Now, in order for us to understand why do we need to automate decisions, I need to tell you a story, a personal story of mine. So I wanted to get an insurance, a health insurance for myself. A couple of months back, I went to Google as usual, looked for a couple of options. I shortlisted some of them, and then I started going to website, navigating, filling information. They asked multiple different questions. I put all the information that I was asked for. And then at the end of that process, I needed to call to an agent to the office to secure my policy and purchase the policy. Interestingly, because I'm in this business, I understand what's happening. When I called to the agent at the office, they had no clue whatsoever I was on the website and filling the form. So there was an absolute disconnect between the customer interaction, my interaction with the website, and the agent at the back that answering the phone. And what is worse is they started asking similar question, even not the same question, with different details. And at the end, the price that they provided me on the phone was entirely different from the price that was on the website. Now, you see the problem here, right? So the disconnect between what customer expects, what marketing puts on the website, what the salesperson on the phone that provide to me, and the product offering that product development puts to the organization with so many different variations, they are all disconnected. And at the end of the day, what is going to be the problem for organization is that they lose the trust in the market. So there is a reputation risk for the organization, and they lose the business. I didn't sign up because how can I trust them if they cannot put the pricing straight? I put the health insurance, my health insurance, in the hands of that kind of organization, right? So this is why organizations need to have the quality, customer-centric situation-aware decisions. When we're talking about the quality, it has a big umbrella. It means the accuracy, it means the consistency across channels. It means that we need to think about the customer journey. It has to be customer-centric. So it is about me. It's not about the organization. So there are multiple different situations. What questions should be asked from me, etc., right? So that's why we need to automate decisions. There are so many details that are happening when we take the decisions that has to be consistent. Otherwise, ends up losing the business to the competition from the organization's point of view, risking the reputation of the organizations. Now, how do we do that? How do we make quality customer-centric situation-aware decisions, right? So that's a big question, and that's why we automate decisions. But in order to understand the how, we need to look at the decision mechanics. So we talk about what the decision is in the business point of view, but in the technical point of view, a decision is like that block you see on the screen. There is an input to an algorithm, which is a decision logic, which produces an outcome, which can be judgment or actions to be taken. Now, that's a building block, the mechanics of the decision. Now, this single building block doesn't solve the problem we taught in this story of mine. So the pricing is not just one block of decision, or the question that should be asked from me is not just one block of the decision on the screen. It's actually multiple of them collaborating together to a final decision to produce the outcome. In this example, calculating the premium for the health insurance, right? Now, all of these different combination of decisions, you can see on the screen, you can block them, you can deploy them, you can do whatever you want to do. But at the end of the day, because the complexity that you see on this screen, you cannot just start automating one. You have to think about the whole broader scenario. So let's say a premium calculation. It has multiple different building blocks working together. There is a hierarchy. There is a dependency. Decisions influence each other. For example, outcome of one decision becomes the input to another decision. So in order to make this whole automation scalable, accurate, and reusable, you have to consider that each individual decision has its own decision cycle. Now, the decision cycle of individual decision has 4 stages. Observe, which allows you to collect the data from different systems, from different data sources, from different applications, from different processes. So you connect to the data, you collect the events, you kind of need to have that connectivity at the first place. Then we need to build the context and information as the input to that specific block of the decision. So Orient is very important, allows you to transform, enrich, validate the data, and create the input for a specific decision that you need to take. In the decide, it's actually the simplest part of the whole decision cycle, because you execute a model, one single block of decision, it creates the outcome for you. Now, this is where it becomes tricky. Many of the automation we're seeing, they just leave the act stage outside of the decision automation. The decision outcome should be actioned. You cannot leave it for another solution, for another time, on the dashboard, for other information system to take care of it. As I mentioned, every single block of the decision has to have all of these 4 stages satisfied. So the act stage is very critical, and it should carry out the action about that particular outcome. It's not just listing the available, for example, offer. What does that mean for the next decision is the act stage, right? Now, observe, orient, decide, act has to satisfy, each decision has to go through this 4 stage of the cycle. Now, every single decision block that we type, because there are so many different types of decision, they require different type of algorithm. So it's not one size fit all scenario. So the decision algorithm might be business rule driven. So rule-based decisioning for that particular algorithm that we discussed. So multiple different ways of modeling business rules. Everyone has its own preference. You talk to, for example, pricing specialists, they like Excel. You talk to domain expert, they like natural language. So we have to provide different options at the end of the day for the individual that doing and the decision automation. And then, of course, they need to understand what happens if we change a couple of variables, what happens if we change the data, etc. So to make this story short, there is no one-size-fits-all scenario for algorithms. So the algorithm of a specific block of that decision graph we discussed might be rule-driven. In other scenarios, other types of decision, it might be data-driven decision. So we use machine learning and statistical analysis and AI to build some type of algorithm to do something. So that can be regression, classification, multi-classification, whatever that responsibility of the specific block of decision is. Now, because we're using in this particular scenario a machine learning algorithm, so it has to be explainable. We can't say, that machine take that decision for us, you have to pay this much. We have to be able to explain why the pricing is appear on the screen is high or low. At least we have to interpret it. Other type of scenarios in decision automation will look at the full hierarchy of the decision that we are automating. There are certain points that the decision outcome can be inconclusive. in those scenarios, we need to involve domain experts. They need to have their inputs to make the decision automation forward. Therefore, a human involvement from the domain expert intervention is absolutely a must in the decision automation as a full picture. And the decisions are not sitting alone in the isolation. They need to interact with information. They need to interact with different systems. They are all not modern systems. They are legacy systems organizations. They have to put the policy back into the core banking system. So they need a robot hand to do the job for them as part of the decision automation in the act stage. Therefore, as you can see, the whole decision automation umbrella comes together as a decision graph, which then allows you to automate every aspect of the decision, not just one decision execution as the decide stage of the cycle. Now, take an example of the decision graph that we discussed for the pricing. It has the component of the business rules. It has the component of the machine learning. It has the component of the orchestration between multiple different systems. And this is where we're going to introduce the next-gen end-to-end decision automation platform, allow you to build the whole decision scenario and automating them and deploy them and monitor them and measure the outcome of and performance of those specific decisions. If you deploy a decision and you don't know what the performance is, you'd better not to deploy that at all, because you need to monitor and see if the performance is improving or it degrading the actual KPI of the business. Are you signing up more people for the policy or are you losing to the competition? So the KPI monitoring is absolutely important in the automation as well. Now, at this stage, I'm going to go and show you one example in real time in our platform. So let me go ahead and stop this presentation. So the environment you see on the screen is our authoring platform. We are about to release version 9 of FlexRule. We named it FlexRule X. Because we significantly redesigned and we recreated the entire platform ground up to make sure we have implemented all the best practices, the UX best practices, the modern look and user interface. Now, here, for example, you can see the home screen. You can connect to multiple different repositories, whether that's online repository or your organization repository, or you can have your different projects, sample project, etc. So I'm going to open the simple decisioning scenario. We simplified this for the sake of this workshop. Now, we are talking in this particular scenario in the calculation of the health premium insurance, the story of my experience with the insurance provider. Now, what should have they done is creating a decision that becomes a single source of truth, allow them to run the decision across multiple channels, the same decision. So I could get the consistent result across the website, across the phone, chatbot, whatever it is they provide. So that shouldn't change really the value I need to pay for a specific policy, right? One of the challenges organizations like insurance take, for example, face is the product development creates multiple different product variation. And this is not really one product, so they have 20, 30 different products and hundreds different variation of the single individual product. And then they push it to the marketing. Marketing puts different, marketing tries to put that on the website, so that's the shop. And then sales try to sell it. So that disconnection can be solved only with the single point of truth using a decision such as what you see on the screen. We call it decision graph in this scenario. Now, if you look at this particular example, this is the final decision that gives the agent or the consumer, whoever it is, the actual pricing that they need to pay. Now, what's going to happen is this pricing has multiple different components. You can see here the base price line. This base price line is a machine learning algorithm I'm going to show you in a minute. That based on the data set we provided, we created an algorithm, we trained it, and it's going to do the baseline pricing. So if I drill down to this particular individual node, you can see another decision graph, a very simple one. And what it does is it actually shows you the information about how you can interpret the result of that machine learning algorithm. So in this particular scenario, we used our AutoML engine that goes through multiple different algorithms. In this scenario, 8 algorithms, 8 iterations, doing multiple different hyperparameter settings to create the best performance. And you can see 82% is the best quality that we have from R2 score. Now, this is permutation feature importance for our machine learning. It will be generated automatically based on the model you create, and it tells you how you can interpret the result of a particular outcome from this algorithm. So you can see gender, sex has a very important input to the whole calculation, and then it goes whether you're a smoker or not, what is your BMI, the age and number of the children. So if we go back to the actual decision here, you can see now in this particular decision, we have the machine learning sitting here. Now, we have some extra charges we can add to the top of that baseline pricing based on the income, based on the cover type they want to apply, based on their residency status. So these decisions down here are not really machine learning driven, they are prescriptive decisions. For example, here. In this particular decision, we are trying to understand how much we extra charge the customer, the consumer, for a specific income that they have. Or based on the residency status, which will be associated to the risk of that particular consumer, how much extra charge we can afford, right? So this part is good. It's the prescriptive. Now, there are so many different situations happening in real life. And as an example, COVID happened, and everyone knows about it. And that changes the premium as well. So let's have a look at that, how it impacts the baseline, which comes out of the machine learning now. So based on the age, based on the place of work, based on they were positive for COVID or not, and some other criteria, you can adjust the value of the baseline. Now, all of that put together, then we can calculate the value for the premium you can see on the screen. Now, once you've done all of this modeling, in FlexRoll Designer, you can put the whole model into the simulation debug mode with providing some sample information. So I'm going to go ahead and put the designer into the simulation mode. What you're going to see is at the bottom of the screen, you see the parameters window. Here is where all the contextual information is sitting. You can have a look at them in details. For example, customer personal data that we had an input. So that's a person, 35 years old, female, 20 BMI, 1 children, non-smoker from Southeast, right? Now, for the extra charge that we need to calculate, we'll need to have some extra information. So that's where the transformation and orient stage of the information comes in place. So we have the customer name, we query the data, that's the observe part, and then we need to transform them in the form that decision model requires it. So we see that's the resident and extra information that we need. All of them put together, we're going to calculate the premium for this individual. Now, in Flexroute Designer, you might want to see, okay, at this particular, for example, decision, in this specific rule, I want to see how the execution is. So you can add the breakpoint here. And if we go back and we run the decision, you can see the yellow arrow stops at this particular rule in the decision table. Now we can see all the information. So for the information down the parameters, and the income of this individual, I guess it was 80,000. So that's gonna not meet this first rule, and it's gonna satisfy the second rule. So if I go back, you can see the green highlight shows that it satisfies this particular rule. Now I go to the next step. I don't go to the details of every single decision for this specific workshop we have because of the timing. Now you can see we're going to execute all these decisions, whether they are prescriptive or predictive. Now in this particular scenario, we're going to execute the machine learning, the trained one that we showed you. Let's go to this particular scenario. And in this instance, we're going to execute it. And you can see the health premium baseline will be calculated based on that. So we have an output of charges for the baseline. Now we're going to add up all of them together and calculate the health premium. So you can see on my screen, that is the price this individual has to pay for the yearly health policy that they want to purchase. Now, this becomes the single source of truth. Now you can deploy it, you can manage it, you can revision it, you can do whatever you want. And by the way, something has happened in the market and we need to add another risk in the situational decision that we have. For example, another pandemic, right? A, B, C pandemic. Now, we just added this simple drag and drop. We can specify what type of algorithm satisfy this particular risk. It can be rule driven. Again, it can be machine learning driven or whatever it can be. It can be even process driven. Now, then simply with adding one single decision as part of the situational decisions like the COVID, now we can change the whole behavior of this calculation. And then again, that becomes a single source of truth. So every channel you have will use this particular decision to do the execution. Goli, do we have any particular question we can answer?
Yes, actually. Somebody asked that how accurate is the ML model can be?
Very good question. So I'm going to drill down here. So ML model is as accurate as your data and the way you look at the data and the way you train the model, right? So in this particular scenario, we optimize the ML model for our score, and that is, you can see 82% accuracy here. Yeah. And the way it explains how we different elements of the information impacts the outcome is defined in the pre-mutation feature importance.
Awesome.
So our AutoML engine, what it does, it goes to multiple different set of algorithms with a single data set, and it runs multiple different hyperparameter and picks the best performing model with a single click by providing the data set. Excellent. So what I want to do is I go back here and I continue quickly to summarize. So an end-to-end decision automation should cover all stages of decision lifecycle. Observe, connect to the data, orient, transform, and create the context for the information to be passed to the decide stage. Decide is the execution of the decision graph that I showed you. And then the action in this particular demonstration, we didn't talk about the action, but now the action is generate this PDF and send that back to the website. Or in the purchase scenario, in the purchasing process, you actually use the same decision graph and the action is reflect the pricing in the core business systems that we have, right? And every single individual algorithm of the single individual decision, which has three components, input, data, algorithm, and produces the outcome, might be implemented with using different techniques. It might be rule-driven, it might be machine learning data-driven, it might be human expert intervention, or it might be collecting some data and inferring some values from that data from different information systems we have in place.
Okay, one of the common applications of decision automation is about data quality. Ensuring the quality of the data is quite complex decision because you want to look at the quality from a different aspect. For example, operations, safety, regulation, and etc. Also, relation between data fields and amounts of data adds to this complexity. A couple of days ago, we had a chance to talk to one of our great customers based in the Netherlands. It's GS1 Netherlands, and I interviewed the data scientist Michael Willig. In just a couple of minutes, we love to share a short video that we talked to him.
I'm Michael Willig, and I'm a data scientist at GS1 Netherlands. And as a part of the Department of Analytics, our role is to monitor the data quality that goes into our system. And that is quite a challenging subject since thousands of products are introduced to the market every day. And somehow we want to make sure that the data quality that is submitted with these products is actual good quality data. And so we use several different methods to validate the data, ranging from very simple rules that we have about the data, like the net weight of a product should never be bigger than the gross weight, but also a bit more intelligence about what kind of sizes are products in certain categories usually, and can we spot outliers within the data. So this is one of the points where FlexRule helps us implement the logic, which helps us check and maintain the quality of the data.
And what is the challenge you were looking to solve that ultimately led you to engage with FlexRule?
Well, our engagement with FlexRule is in part to empower our business users to use more of their knowledge in a way that we can implement the solutions with them. And so this is one facet of it, to give the business the tools they need to be more in control of things. And this helps both in communication and actually solving the puzzles that need to be solved. But as a second side benefit, it's also very useful as a tool to explain to other people what exactly a process is doing. If you can do it visually and if you can step through it. And this is one of the benefits that FlexRule also provides.
Great. Arash, I can see some questions here.
Excellent.
Okay.
Let's pick
Great.
them.
First of all, can we use our own custom ML models?
Absolutely. So as part of our solution, we have bring your own algorithm scenario. So you can bring your own algorithm in different ways and integrate that into the decision graph that I showed you. One of which is using PMML. So if you use any data scientist platform, you can create PMML, export your algorithm, save them as a PMML, and bring them here, reference it in FlexRule decision graph, and execute them as part of the decision execution. Other way is you host your algorithm as a service, and then in decision graph, we can call to that service, sending the required information. It executes and receives the result back, and it continues down the track of executing the actual hierarchy of the decision.
Okay, that's cool. The next one is, can we get the decision stack? That is how the final decision was arrived at.
Absolutely, and that is where it comes to the explainability. So when you execute a particular decision, I can actually run it and show you here. So let's run this particular decision. I actually need to delete the ABC pandemic. It hasn't happened yet. Hopefully never happens. Don't blame me. So now we executed this particular decision, and we can see now all the details information about how we come to the conclusion about the result. For example, this is going to the machine learning. This is going to a particular rule that satisfies this particular extra charge, etc. So you can see the full visibility about why did we come to the actual outcome based on the particular input.
Okay. The next one is how and where we can deploy the model that you showed.
Absolutely. So there are multiple different options for deployment. If I found my mouse here. Okay. Now, let's say that's your decision you want to deploy. You click on this button and you put the package builder into the deployment option. You can see there are multiple deployment options are available. So if you want, you can go with the serverless deployment that out of the box we support Azure Function, AWS Lambda, and Cloud Function, Google Cloud Function. So you can deploy them, select them, put the information about your subscription account you have with any of these cloud provider, press the publish, and it publishes that to that particular cloud. You don't need to do anything. The service will be available, which at that point it gives you two endpoints. One is for service discovery, which supports all the constraints related to the input for that service, and it also supports the Swagger information. Also, the endpoint for execution. So you call to that particular endpoint with a set of JSON payload. It executes and returns the result back to you. So that's a serverless solution. You can go with your own platform. So you can deploy FlexRule Server, build the decision execution platform, and then you deploy to FlexRule Server as part of your deployment strategy. And then again, that becomes a service endpoint. So when you deploy any model, including decisions you see on the screen, becomes a service endpoint at the end of the day. You pay the JSON payload to the service, it executes and returns the result back. And also it can include all the information about why did we come up with this particular outcome, like I showed you on this screen graphically, as part of the result JSON.
Okay. We have just 7 minutes. We have too many questions. If you don't have time to answer everybody's questions, I will personally send an email and answer your questions. But we have just 7 minutes, Arash. How is the model trained? The model that you showed, how did you train it?
Absolutely. So if you see on the screen, there is a machine learning algorithm, machine learning menu here. There is an AutoML builder, and in this particular scenario, we trained using the regression. Now you go here, you open your regression screen, you load your data. I don't have a data set here right now, but what it does is it actually starts adding the information data set here, and then another step. Let me actually see if I can find. There we go. So we added this particular instance here. Now you can see the preview of the data. This is our data here. Now we go to the next step. We say, what do we want the outcome of that particular model would be, and based on what input parameters. Then we go to the next step, and we do the start. And what's going to happen is at the back of this, you can see here in the background task that I have, if I expand that, it's going to use my data set. It goes to multiple different iterations. It generates the algorithm for us, and that's it automatically creates all the decision related to that as well. So this is what I just created here. And if I open that, you can see this is how it performed.
Okay. Interestingly, we have a question about our RPA. Can you elaborate a little more on the advanced RPA capability that you mentioned on slide 4 or 5?
Absolutely. So we don't call it RPA for a very good reason, because we call it decision robotics, and that allows you to build robots that actually can take decision. And the reason is we have a fully integrated decision mechanism, as I showed you here, and one step of that, it can be the robots doing something. So we have all different set of application connectivity. You can automate website, you can automate Windows-based application, you can automate command shell, you can automate interaction between the robots and different type of application. And in one step, when you collect the data from different systems, then you can pass that to the integrated decision mechanism that you have, for example, as part of that bot action, and it takes a decision. Because we have the integrated business rules, machine learning, and decision-making mechanism into the solution, into the bots, we call it decision robotics.
Okay, and can we copy and paste multiple activities?
Absolutely, you can.
And then we can reuse it in another scenario?
Absolutely, we can. Absolutely. And then copy and paste is just a very simple way. But the better way to do that is actually, let me create here for you very quickly. You can have a process that represents what you want to do. And it's better than copy and paste because you can simply drag and drop that particular decision here. I just make it very simplified process. You can look for different data. Let's say we need to connect to the data. Let's say that's just two-step process. And if I open this particular node here, you can see that's exactly the decision we just tested and deployed.
Okay, sounds good. We have one question about versioning. What kinds of versioning do you provide?
So versioning happens in two different steps. One is at the development step, which you use Designer and you do the revisioning and versioning, etc. For that matter, we support the Git. We have a built-in Git integration. You can see on my screen, I just committed, for example, I can commit init commit. I can commit all of this and I can push it. So we have integrated, built-in integrated Git integration into the platform that you see in authoring environment. The other part of the versioning is service versioning, which we can support multiple service versioning running in parallel. You can switch between them. You can monitor the performance of different versions of the service and etc. I hope that answers your question.
Okay, the last question, and we will finish the session. Do we have breakpoint in data table?
Absolutely, you have. And I think I showed you, but it might not be clear. So if I go to the COVID, you can add the breakpoint here at this point. You can see I'll right-click and add the breakpoint. And what's going to happen is it puts this breakpoint mark here. And when you execute, it stops at this point and you can take over.
Great. There are too many questions, I guess. We can just answer one more, Arash, and then we finish the session. What algorithm is used for business rules execution? So
we have multiple different algorithms because as I mentioned, it's not just a business rule engine that it matters. It's the whole combination, and the algorithm that we execute for rules is a combination of the read and procedural and inferring algorithm that we develop internally.
Okay, fantastic. I guess
yeah,
45
excellent.
minutes, you're done. Thank you so much, Arash, for all of the effort. Guys, we have too many questions on the QA box. I will make sure that I will answer all of them by tomorrow.
She's not going to sleep then.
Thank you so much for joining us. And if there is any feedback that you'd like to share, we are open to hear all of them. You will receive a couple of emails from us. The recording session will be sent to you. Also, we prepared a couple of good materials that we'd like to share with you through email.
The most important thing here is if you want a custom demo for yourself and organization, please send us an email to myself or Goli, and we can arrange a specific example of yours, modeling, execution, answering one-on-one questions on the session.
Great. Thank you so much.
Thank you, everyone. Thanks for joining.
Have a good evening.